You ready? Hey, welcome everyone. It's 2023, and we're at B Street for our fifth year of doing this. Actually, it's crazy. We've been blacking out at B Street for 5 years now. All the patrollers that don't have to work on Fridays. But yeah. Tonight we have Jim Steenburgh. Hey, quiet in the back, Ethan. Hey. Shh. Anyways, Jim Steenburgh here, the professor of POW. He teaches for the... Yeah, let's give him a warm welcome. He teaches in the Atmospheric Sciences Department at the University of Utah. He literally wrote the book on weather in the Wasatch. Shameless plug there for Jim. Buy it on all your buying things. But yeah, let's give a warm welcome to Jim coming up from Salt Lake. Thanks guys for coming out again.
Thanks, Corey. Thanks for having me up. Everybody having a good ski season out there? I have been waiting for this ski season for 12 years, since the 10-11 season. To have a snowpack like this and the low angle sun right now is incredible. It's like every aspect is in, every approach is in. We had this persistent weak layer. It's a little bit of a minor complaint or serious complaint, but man, what a winter. It's been really awesome. And for me, I don't get much work done when the winter's like this, because between the skiing and wanting to forecast the weather all the time, it's really pretty exciting. So today I'm going to talk about the secrets of the greatest snow on Earth. A few years ago, you know, when you're a meteorologist and people find out you're a meteorologist and you're riding on a chairlift, they start asking you all kinds of questions, like when the next storm's coming in. Is Utah's snow really the greatest on Earth? And all these questions kind of came together and formed the first edition of this book that came out in 2014. And the second edition will be coming out next winter. So I'm pretty excited about that. It includes a lot more microclimates all around the world. So I thought I'd start today talking about what the secrets of the greatest snow on Earth is. When I wrote the book, I had the entire book done, except for the first few paragraphs of the first chapter, which sounds kind of crazy. But I really wanted to talk about what the history of the greatest snow on Earth phrase was. Where did greatest snow on Earth come from? It's like one of the greatest slogans in the entire outdoor industry. Somebody had to come up with it. And it turns out there had been a lawsuit over this phrase. The Ringling Brothers and Barnum and Bailey Circus sued the university or the state of Utah for trademark infringement because they were the greatest show on Earth, and Utah had done greatest snow on Earth. So I figured, and actually the lawsuit was the state of Utah won. They basically decided it didn't infringe on Ringling Brothers and Barnum and Bailey Circus in any way. But I went through all the court documents, figuring that somebody had to figure out where this phrase came from, but nobody knew. They didn't know where it was. But I had an ace in the hole. I don't know how many people here have ever met Dave Hanscom, but Dave is like a legend in the Nordic community. And for the old school people, might remember this, the new schoolers maybe not, but Dave and Alexis Kellner wrote the original backcountry ski book on the Wasatch Range. It's a 3-volume edition. There's like a basic one, and then there's like the Southern Wasatch, the Central Wasatch, and the Northern Wasatch. Dave was one of those people. So I called him up one day and I said, Dave, do you know where the phrase greatest snow on earth came from? And he said, I don't know, but I think a guy named Mike Karolagos does. And I put off calling Mike for the longest time. And finally, it was at a function at the Utah Natural History Museum at the University of Utah. There's like 1,000 people there, and there's a guy standing next to me as a name tag on, and it says Mike Karolagos. And I was like, perfect, I'll ask Mike where the phrase came from. So I asked him, and he said, oh, my brother invented it. And I thought, yeah, right, tell me another story. And so he gave me his brother's email, and I sent his brother a note, and I asked him, hey, who came up with the phrase? He goes, yeah, it was me. Turns out this guy was a lawyer in Philadelphia. He's like helped several Supreme Court justices get through the confirmation process. He's completely unimpeachable. And he told me it's going to be I first used it in the early 1960s in a Salt Lake Tribune article. So I spent like 2 weeks in the Marriott Library going through old Salt Lake Tribunes. You can do this now in 10 seconds with Google. But back in the day, I was doing this, and sure enough, there's the first use of the phrase greatest snow on earth in print. This is in the Salt Lake Tribune Home Magazine, December 4th, 1960. And what Tom wrote is that Intermountain folk will tell you that the winds blowing from the west leave the wet, sticky snows in the Sierras. He didn't experience this year, apparently. When the storms reach the Intermountain ranges, only the most perfect dry powder is left. That's just a sprinkling of what you'll find in this vast scenic country. And he goes on and on and on. And he goes, that's the extent of the Intermountains Big Top, which supports this real, true, greatest snow on earth. And that was really the birth of the legend, December 4th, 1960. Well, let's talk a little bit about why Utah snow is the greatest on earth, okay? And of course, the conventional wisdom, there's quotes like this, which I pulled out of various ski magazines. The greatest snow on earth is more than a catchy slogan. It is a scientific fact that Utah's snow is lighter and drier. And because of the high salt content of the lake, storm clouds create a unique type of snow that is particularly light and dry. Experts call it the lightest, driest snow anywhere. Scientists have a phrase for phrases like this. It's called bullshit, okay? None of this is true. In fact, most of what you read in the literature, like in ski magazines and stuff about what snow is like around here, is just a bunch of crap. It's really pretty incredible. And, one of the dirty little secrets of the Utah ski industry is that the snow here is not even all that dry. The driest snow in North America falls in Colorado, it falls in Wyoming, it falls in Montana, and it falls in the lake effect snow belts of the eastern United States. On average, if you go downstream of, say, Lake Ontario, the snow there is drier than it is in Utah, okay? Yes, exactly, yeah. But it's also a myth that the best powder skiing is in the driest snow. And I really like this quote by Ed LaChapelle. Ed LaChapelle is kind of the grandfather of snow safety and avalanche research in the United States. So he was recruited to go to Alta by a guy named Monty Atwater, who was an early snow ranger at Alta. And he was trained in Davos in Switzerland at their great Avalanche Institute there. And in 1962, Ed wrote that the best deep powder skiing is not found in the lightest snow, but rather in snow with enough body to provide good flotation for the running ski. And I tell people all the time, the best deep powder days are not the days that's cold smoke, all cold smoke, but on the days that are really right side up, starting out with high density snow and the storm finishing with low density snow. So that's what you want for ski flotation. That is the hero snow. So the real secrets of the greatest snow on earth in Utah and why Alta, for example, I'm going to use Alta for this example. I'll talk about Snow Basin and Powder Mountain later, maybe. Yeah. Well, hold on. There's a little history here. Alta became well known and became the birthplace of deep powder skiing methods because, there was lift serve skiing there and at Brighton before there was anywhere else. If you go to Austria, the Arlberg, St. Anton is famous for alpine ski technique, which at the time was about just turning skis on packed snow. And it was Alta that really deep powder ski techniques were first developed. And the secrets of the greatest snow on earth are we get a lot of snow. We have abundant snowfall. There are places that get drier snow, Colorado, for example. But have you looked at how little snow they've had this year? Have you looked at what their base steps are? Pretty lame. Exactly. Lame. This is being recorded, right? Good. Yeah. There's something else. We have lots of Goldilocks storms. Okay. So, I lived in Washington for a while. And, not only is the snow heavy there, but oftentimes the storm cycles there are enormous. Or go to the Sierras. The Sierras get so much snow that everything gets shut down all the time. What you really want for deep powder skiing is regular storms that are like 10 to 18 or 20 inches of snow. You start getting over 20, the ski patrols will tell you everything starts to get shut down. So you want lots of these Goldilocks storms. In the Cottonwoods, it's 18 days a year with 10 inches of snow or more. So that's a pretty good ratio. Every 5 days, they average a 10-inch storm there. And then the last thing is we have a climatology here that favors lots of right side up snowfalls. So we get a lot of storms that start out warm, they produce high density snow for a while, and then they get colder with time. That's optimal for ski flotation. There's other places that get lots of upside down snowfalls. You experience them at Snow Basin from time to time, I've been told. But it happens. And 20 inches of snow right side up versus 20 inches of snow upside down skis totally differently. So anyway, those are the three secrets of the greatest snow on earth. Let's talk a little bit about Wasatch microclimates. And it was really microclimates that got me into meteorology. I grew up in upstate New York, and I lived in the Adirondack Mountains, but I used to go to Tug Hill all the time to go skiing, Tug Hill Plateau. Little known fact, the most intense snowstorms in the world occur in New York State on the Tug Hill Plateau. I've actually done field work there. It's pretty incredible. But I'm not the first meteorologist to think about this. It's a pretty interesting story. Back in the 1930s, there was a meteorologist. His name was S.D. Green, and he was a ski tourer. He used to take the train to Park City, and then he would overnight to Brighton Basin. That was the original Utah Interconnect, okay? And I think I got to read this from looking back here. 1935, this meteorologist wrote that skiers will eventually find that the heads of the Cottonwood Canyons offer the best skiing to be found in the Wasatch Mountains. And he of course, he didn't know about Snow Basin at the time, I know. But he basically in the 1930s was arguing that the Cottonwood Canyons were the sweet spot for deep powder skiing, which is pretty remarkable. Think about that in the 1930s, what they were skiing on for equipment for S.D. Green to do that. And, really Utah's powder reputation is built primarily on what happens in Little Cottonwood Canyon. Secondarily, what happens, I think, here in Powder Mountain and Snow Basin. I have to, Park City gets incredibly less snow than Alta for as close as it is to it. So I have a map here. This is just the average annual snowfall in the Wasatch Range, and you can kind of see the ring of very high values in those two alpine ridges that surround Little Cottonwood Canyon. And in fact, snowfall at a given elevation in Little Cottonwood is about 40% greater than it is on the Park City ridgeline. And they're only a few kilometers or a few miles apart. It's really quite remarkable what a microclimate it is. And then if you move here into the northern Wasatch, it gets snowy as well. The nice thing about Powder Mountain, Snow Basin I know a little bit more about. The advantage of Snow Basin compared to Park City, they're both on the east side of the Wasatch Crest, but Park City is on the east side of a much wider part of the Wasatch Barrier. Snow Basin is sitting really right on the high crest. So Snow Basin gets quite a bit more snowfall for its elevation than Park City does. And then there's Ben Lomond, which is my favorite microclimate in Utah for reasons we'll see in just a minute. People often ask me, what's so special about Little Cottonwood? And in Little Cottonwood, what's so special about it is the Wasatch get a little wider there. And so the Wasatch overall are running kind of north to south, but there are these two ridge lines that run east-west around Little Cottonwood Canyon. It doesn't matter what direction the wind is blowing from, it has to go up and over this island of high topography. So Alta has the greatest diversity of winter storms in the Wasatch.
If the flow's out of the southwest, they get something. If it's out of the south, they get something. If it's out of the southeast, they get something. If it's out of the northwest, they get something. If it's out of the west, they get something. They always get something, okay? That's why they average over 500 inches of snow a year. But then you go to a place like Ben Lomond. How much snow did Ben Lomond get this week? How much water? 7.5 inches of water, I think, in about 2 days. 2 days, I think it was. 7.5 inches of water. Just absolutely sick. Ben Lomond has a less diverse storm spectrum. But when it comes out of the south or the southwest, they get completely hammered, okay? And the reason for this is that Ben Lomond and Willard Peak, the whole massif there, sticks out to the west a little bit, okay? So you think about the ridge line that comes up, snow basin, and then all of a sudden you get out to Ben Lomond and Willard Peak, and this thing juts out a few kilometers to the west. And what this does is it creates a terrain concavity. And I've tried to illustrate that here. I don't think I can quite do the pointer. Anyway, what happens is that it creates a terrain concavity, and that focuses the flow right in that area around Ben Lomond, creates what we call low-level convergence, which forces enhanced rising motion. So when we get flow out of the south and the southwest, Ben Lomond tends to get incredible amounts of water equivalent. Sundance also sees effects. It's not quite from the convergence, but just due to the sheer size of Mount Timpanogos when flow is out of the southwest. They also see enormous snow liquid water snowfalls. But Ben Lomond, I always like to say, is pound for pound the snowiest place in Utah, okay? When you look at the Ben Lomond snow tell, it's only at 8,000 feet, and the water equivalents there in a good year are really phenomenal. And I used to, a long time ago, okay? I still do this occasionally, but not amongst the meteorological community. Very few people could believe the data from Ben Lomond. And back in the day, when I first moved here, I was going up there ski touring a lot, and my students were very skeptical. So in this particular day, in late April, I took a group of graduate students up, and I made them dig a 13-foot snow pit on Ben Lomond. It was definitely not up to professional standards. But anyway, on this particular day, is 156-inch snow depth near the snow tell. We didn't do this at the snow tell site. If you go up to Ben Lomond, leave the snow tell site alone. But near it, it's 156 inches. At the same time, at Alta, it was 165, but Alta measures at 9,700 feet, 1,700 feet higher. So I like to say, pound for pound, Ben Lomond's the snowiest place in Utah. And we can look at this year. Interesting aspect. Right now, today, the latest measurements. Ben Lomond snow tell, 33.8 inches of water. Snowbird snow tell, 30.9. So you can look right down your noses at those folks in Little Cottonwood Canyon. Okay. Interesting story too. The Snowbird snow tell is at 9,100 feet elevation. Ben Lomond's only 8,000. So is it 7,600? I thought it was 7. I thought it was close to 8. Really? Well, even better yet. So pound for pound, even more impressive. All right, let's talk a little bit about some other things that happen here in the Wasatch. The Wasatch are a very narrow mountain range. Most of the meteorological research that's been done looking at mountain precipitation has looked at really wide mountain ranges, like the Alps, the Cascades, and the Sierras. You know, Snow Basin is an incredible place. It's a remarkably narrow barrier there. And so Snow Basin and the Park City side, they really rely on we call spillover. So we actually, many years ago, had these mobile Doppler radars that we operated upstream of Snow Basin. And we were able to use these Doppler radars to paint out the whole wind field around Snow Basin. And what you find is when the flow is out of the west or the southwest is the air is rising at an incredible rate. It's around 6 or 7 knots going up on the windward side, okay? So when we think about it, in meteorological speak, using non-US units, it's 3 meters per second, which is about 6 knots. That's how fast the air is going up on the windward side of the Wasatch, which is an incredible number, okay? And all that does is generates snow very quickly, but it gets carried downstream and it falls out on the lee side of the barrier. And so at a place like Snow Basin, you basically are getting lots of spillover. If you were farther downstream or the barrier was wider, it would be a lot drier. So Park City at a given elevation, it actually gets less snow than Snow Basin, in part because the central Wasatch are very wide. Or if you go to the Cascade Mountains, say, of Washington, there's a ski area near Wenatchee called Mission Ridge. It's a great little mountain, but it's heavily shadowed all the time because the Cascades are so wide. But Snow Basin has the advantage of being near the crest on the lee side of a narrow barrier, so it gets lots of spillover. It also gets a lot of wind, from what I've been told, right? So now this isn't such a big deal around Snow Basin because you're close to the crest, but Deer Valley's actually gotten a lot of snow in the last few storms, and they tend to do pretty well in southerly flow or southeasterly flow. Those are situations where the lee side rain shadow or precipitation shadow is not as strong. Okay, and so I mean it's incredible. Deer Valley's got over 100-inch base right now. They might be using a relatively short yardstick to measure that, but it's still pretty impressive. First two questions asked by every Deer Valley skier. Do you know what they are? How much did it snow last night, and what runs did you groom? Come on, give me a break. People always ask me what my favorite snow climates are, places that I like to go skiing. So I was going to talk a little bit about that. I lived in Seattle for 6 years. And granted, the snow is definitely of lower quality than Utah's, but man, does it snow a lot in the Cascades. And the spring skiing is amazing. The ski touring on the volcanoes is amazing. So I like to always point out that the world record snowfall in a season was set on Mount Baker in the Northern Cascades, 1,140 inches of snow in the 1998-99 ski season. I've always liked this photo. Mount Baker sent it to me. That year they had to close for a few days in February to dig not just the start and end points of the lifts out, but they had to dig out the track for the whole chairlifts. They had to dig out to basically because it was so buried up to the lines. Pretty amazing stuff. Great Lakes of North America, really impressive too. Anybody from back east here? My Midwest. So I grew up in upstate New York, and my first deep powder days were at a little ski area called Snow Ridge, which was on the backside of the Tug Hill Plateau with 450 vertical feet of snow. But when it was deep there, it was pretty good. Definitely wasn't Utah skiing, but it was pretty good. Actually, the snow quality there can be really good. They just get these are the most intense snowstorms on Earth. You might have read a lot about Buffalo. I mean, 30 people died in this last event in Buffalo. And people from Utah have a hard time recognizing this, but it snows 5 inches an hour in those storms, nonstop, with wind sometimes. And it's just really, really difficult. If you're not home, if you're out on the road, this is what happens. People get stuck in their cars. They die from carbon monoxide poisoning or from exposure, especially if you're older. So it's serious stuff. I was really lucky a few years ago. I got to live in Austria for 6 months during the winter. And of course, the Alps are the kind of the birthplace of alpine skiing. And I usually like to give a few tips to people if you're going to think about going to the Alps. Of course, this year you shouldn't be going. If you went over Christmas, I apologize. But what's interesting about the Alps is it's such a big, wide barrier that the most precipitation falls not in the highest terrain, but actually on what's called the Alpine Rim, which are the lower mountains that are around the edges of the Alps themselves. So if you go to, say, northeastern Italy and western Austria, a place called the Tyrol, okay, in Italy it would be the Südtirol. The South Tyrol was all part of the Tyrol back before they broke up all these countries after World War I. It's a really interesting thing, but it snows more in places like the Arlberg on the north slope of the Alps and in the southern Dolomites than it does in the high terrain in the central Tyrol. The hard part there is that those mountains on the rims are also a little lower, so they also see wetter snow and rain from time to time. So it's always a debate there about would you go to the interior to places like Obergurgl, where it's high altitude and the snow's a little more consistent, or do you want to be on the rim where the snowfall might be a little bit greater, but you might see some more variable snow conditions? So that's kind of an interesting thing. But personally, my favorite snow climate is Japan. I went to Japan for the first time in 1998. I went to the 1998 Winter Olympics in Nagano, Japan. Salt Lake Olympic Organizing Committee sent me over there to learn about weather support for the Olympics. You know, the internet at that time was pretty new and Japan was pretty undiscovered. And when I got to the Hakuba Valley, I could not believe how much snow there was. And I was there, the 98 Nagano Olympics got so much snow they had to keep canceling alpine ski races. One day they canceled the Super G, and I went skiing at Hapo-Ona, and I had the whole place to myself, powder skiing. It was really an incredible experience. And I got to go back in 2017 as well. But Japan, I tell people, Utah is the greatest snow on Earth, but Japan is the greatest snow climate on Earth, by far. It's the biggest snowmaker in the world. It's the surest bet for deep powder skiing anywhere in the world is Hokkaido Island in January. And that's because they get what's called the winter monsoon. Monsoon's a word that means season, and it has to do with airflow changes. And when you start getting into December in Japan, Japan lies to the east of Asia, the whole Eurasian continent. It's the biggest continent in the world. It's also the coldest air in the world. It's outside of Antarctica during the wintertime. And you get lots of cold surges, and the cold surges move across the Sea of Japan. The Sea of Japan is 12 times bigger than Lake Superior, and it has a warm current that flows up the west side of Japan. So they just get inundated in lake effect snows, nonstop almost, for a good chunk of the winter. And when you look at a place like Kuchen, this is on Hokkaido Island, I have a comparison here of the monthly annual snowfall at Alta, which is in blue, with the monthly annual snowfall in Kuchen. And you can see there in January that Kuchen averages about 150 inches of snow in January, which is almost double Alta. It's the surest bet for deep powder skiing anywhere in the world. And if you go along the kind of the western side of Honshu, it's the same thing. Enormous amounts of snowfall. Great place to ski. Should I wrap up, or do we say a little bit of avalanche history? Okay. I have a chapter in the book. It's called Alta Goes to War. It's about the avalanche history of Little Cottonwood Canyon. And I like to talk a little bit about it. This is what Alta ski area looked like in the late 1800s. Completely denuded of trees, okay? Silver miners came to Alta in the 1800s. They were trying to mine silver, and they just cut down everything in sight to build buildings and to keep warm in the wintertime. Imagine what the avalanche conditions were like then compared to now. And just to kind of give you a little bit of a perspective, if you know that area, there's High Rustler, Eagle's Nest, and Mount Baldy. So not a single tree anywhere in areas that we see trees now, anchors that help to keep the snowpack in place. And if you look back through old literature, this is from the Salt Lake Tribune in 1884. Since mines at Alta were first opened 14 years ago, 143 people have been killed by snowslides. Ogden Avalanche wasn't around then to help people out. Utah Avalanche Center wasn't around. It was a pretty dangerous place. And I usually like to tell people when people say, why do you spend a lot of time trying to forecast the weather in Little Cottonwood? I usually tell them because if Mother Nature is left to her own devices, it's one of the most dangerous places in the United States. It's not an exaggeration to say that. The highway that goes up Little Cottonwood Canyon has the highest uncontrolled avalanche hazard index of any major road in the world. Okay. And so what happened was silver mining died out. Little Cottonwood became a pretty quiet place, but eventually in the 1940s, it began to get developed for skiing. And as soon as it started to get developed for skiing, people wanted to ski powder. I see young people like you all today, you think you're the first people to ski powder, but you didn't, okay? You're not. People at Alta in the 40s were trying to ski powder in the backcountry. So there's a great quote here by U.S. Forest Service Supervisor Felix Koziol, 1946, winter skiers wander all over the landscape. Many are not content to stay on the practice slopes and on the ski runs close to the lifts. An increasing number are seeking ways to get far out into the alpine hinterlands, far away from the snow bunny crowd, okay? So people wanted to ski powder. They've wanted to ski powder at Alta for a long time. When you look at Little Cottonwood today, this really hasn't changed with time. There's 50 major avalanche paths that intersect the highway that goes up Little Cottonwood and the various roads and the village of of snowbird in the town of Alta. And one thing that is changing, though, the preferred weapon for dealing with avalanche control in Little Cottonwood has been howitzers over the years, 105 millimeters, and they're still using them. And I'll show some examples, though, of how they're trying to cut back on the usage. But there's increasingly they're putting in GasX exploders. I've seen these also at Snow Basin. I don't know if you've put them in at Powder Mountain. These active control systems. Yeah. Avalanche control by cell phone, of course. A lot of these Wiesen towers. I first encountered these Wiesen towers in Austria, and I wondered what the hell they were. And then I looked around and found out that, yeah, these are really kind of neat. There's these, they can fly these in by helicopter, has a bunch of charges in them, and they can lower them and detonate them to help trigger avalanches. And the reason why this is important is because Alta is the only place in the United States where live artillery is shot over the heads of civilians. Okay? And if you've heard of interlodge, when people go into interlodge, it's because they're shooting these large guns. So the priority has been over the last few years to use GasX and Wiesen tower systems to try to stop shooting shots that go directly over buildings. Okay, and so here you can kind of see, these are all the various shots that they do in Little Cottonwood Canyon. There's red and white ones there. I have to try to remember which ones are which. I can't quite see, but some of those, the white ones I think are over buildings, and they're trying to get those down to nothing, so that the only shots they're doing now are going to be at least not over buildings from a safety standpoint. And in the long run, the plan is to try to get rid of the howitzers. In some ways, that's sad, but it's actually a very safe thing as well. But I like to tell people, never turn your beacon off in Little Cottonwood Canyon until you're out the bottom of the canyon. This actually is a snow slide from 1988 that hit a UTA bus in Little Cottonwood Canyon. So with that, I'll be happy to take questions. I'll knock off. If you're interested in reading more, you can get my book on Amazon, first edition. Second edition will be out next winter. It includes a lot more on climate change, which is kind of disturbing, but also on microclimates of Japan, the Alps, and some few other areas. So thank you so much for having me up here tonight. Questions, anything, back there in the back. So I think I can paraphrase. She's asking about lake effect. Right. Yeah, what's happening with the lake shrinking? Well, the good news is the lake will probably come back a little bit this summer, hopefully, but not a lot. So the kind of the crosshairs for lake effect is the cottonwoods. My group did quite a bit of work a few years ago. We went through about 10 or 12 years of radar data, and we actually figured out how much of the precipitation around northern Utah is associated with lake effect periods. You can't completely separate lake effect from non-lake effect snow, because sometimes you have pure lake effect events, but there's others where there's both lake effect and other precipitation processes going on. But during lake effect periods, it was about 5% of the snow in the cottonwoods. During water equivalent snowfall in the cottonwoods is produced by lake effect, and it would be smaller amounts up here around Snow Basin, maybe around 1 or 2%, and probably pretty close to zero. By the time you get to Powder Mountain, it drops off pretty quickly as you move inland. So the numbers are lower than people think. This year's a good example. We've had hardly any lake effect storms, right? I mean, we've had lots of these southwesterly flow events. So, you know, I think it's overemphasized a little bit, but it's still important. I don't want to say it isn't. 5% snowfall, still 5% snowfall. As far as what's going on with the lake, you know, we've never tried to quantify what's going on, but it's obviously not a good thing. I mean, the lake is right now is confined to almost, I call it the Great Salt Finger Lake. You know, most of Farmington Bay is gone. There's just a little ripple of water, mostly associated with the Jordan River there. And as the lake continues to shrink, it will be confined more and more to a narrow channel that runs from northwest to southeast. That's kind of the deepest part of the lake, where the last bit of the lake will survive. I mean, the good news is right now we've got a really fat snowpack, and hopefully we'll get a pretty good runoff. I mean, we just don't know what's going to happen. You might remember last year we kind of hit the doldrums and we really had very little snowfall for 6 weeks. If we had something like that happen now, you know, we'd be looking at maybe an average runoff, but if it can keep coming, we might have a better than average runoff. And then it's just a matter of how much we siphon off before it gets to the lake. But 1 year is not going to be enough to save the lake. We have to see what happens with time. I'm personally pessimistic about the long-term future of the lake, but I'm hoping it'll hang on for the rest of my lifetime, and hopefully the rest of yours too. So, other questions? Yeah. So the question is, what's happening on the west side of the Crested Snow Basin? The answer is, I don't know. It obviously snows there, but I have not spent enough time on the west side of the divide to have really much of an intuition of what's happening there. I would just be total guess on my part. Yeah.
I would say probably melting on the west side.
Wind, yeah.
Nothing really happens on the west side because that's coming out of the east, so this doesn't really happen. But going back to like the lake effect stuff, I kind of have a general idea about it, but I don't know, maybe I'm wrong, how many people actually know what lake effect means.
Yeah, so lake effect is precipitation that's generated or enhanced when cold air masses move over warm bodies of water. And when there's a whole host of things that happen when cold air moves over a warm body of water. One, probably the most important, is there's a transfer of heat from the lake into the atmosphere, so it destabilizes the atmosphere. But it also can generate what we call land breezes. So as the air over the lake gets warmer than the air over the surrounding landmass. And so when those land breezes, they oftentimes become the focus point, the focal point for triggering precipitation bands. So there's this cascading effects. A lot of people talk about pumping moisture into the atmosphere, and there is some moisture transfer from the lake into the atmosphere, but a dry atmosphere, a dry cold air outbreak won't produce any lake effect, at least on the Great Salt Lake. On a big body of water like Sea of Japan, that's not a problem. But the Great Salt Lake is pretty small. The characteristics, the amount of moisture in the upstream air mass is really important because the lake is hypersaline, it's super salty, and that reduces the amount of water transfer from the lake into the atmosphere. So we've done work, and if you don't have a relative humidity upstream before the air mass gets to the lake of about 70% or higher, you're probably not going to get any lake effect precipitation. So you want to have a kind of a juicy air mass to start. That's kind of the best situation. So.
Jim, we got a question from the internet here.
Yep.
Question from Facebook. Can we get a copy of the presentation?
Oh, a copy of the presentation?
Yeah. Or just buy the book?
Yeah, buy the book.
Okay.
Buy the book. I get at least $50 from every book that's sold. I've almost paid for my expenses of publishing the thing. So yeah.
What's a good source for a layperson to look at historical water total falls for
Northern Wasatch is tough. The Alta Guard data is available on the Utah Avalanche Center website. If you just Google Alta Guard snowfall, they have a record back to the mid-1940s of water, I think water equivalent and snowfall every month. But up here in the Snow Basin area, I don't really know of much that's available. I'm certain that the Snow Basin Ski Patrol, for example, has it, but that's going to be an interior. There's oftentimes the case in mountain locations that the snow safety teams have better archives than the meteorological staff. If they don't share it with us, it's basically we don't know about it. So.
I'll share it.
Second question, what's the closest lift service ski to the Bengal microclimate?
Nordic Valley. Yes. Thank you very much. I am so embarrassed I didn't mention the great microclimate at Nordic Valley. It is today. It might be bigger tomorrow. Any other questions? This is the Ask Me Anything moment. How about here, Paul?
With climate change, do you predict
Well, I think the atmospheric rivers are a regular part of our climate before climate change. It's just that the term atmospheric river was never even used by scientists until the 1990s. Okay, so there were some scientists that decided to give a name to this phenomenon, and all of a sudden it's becoming part of the public vernacular. So it's kind of like they've been around for a while. But the expectation is that they will probably shift into a situation where they become a little less infrequent and a little more extreme. And I think that's kind of like from a climate change perspective, in terms of snowpack and avalanche conditions, the things that I think are going to be most important is we're going to see a greater fraction of precipitation falling as rain instead of snow. And that shift will be largest in the low elevations. You can see that happening in the valleys now, right? I mean, think about all the precip we've had, and there's virtually no snowpack here in Ogden or in Salt Lake City. And so the losses are not going to be equal. It'll be much bigger in the valleys and much less at high elevations. The second thing is the tendency for storms to become a little less frequent and a little larger. So that's kind of a general expectation is that the storms are going to become bigger and a little more widespread. So I'm not saying this year is a reflection of climate change. I'm usually very careful about that. I mean, it'd be kind of crazy after going through 15 years of drought to run around saying that it's going to be like this from time to time. I tell people there's a lot of variability in the climate system. Moving forward, there will be a lot of variability in the climate system, but we're shifting into a warmer climate. So greater fraction of precipitation falling as rain instead of snow and bigger storms is expected.
Follow-up, Court.
Yes.
With the warming of the climate, does that mean that Utah is going to become more moist even in the summertime? Or?
No. I don't think we really, there's two parts of this problem. Like, how is temperature going to change? And we have a lot of confidence it's going to keep warming. Precipitation, though, our computer models are all over the place in terms of what precipitation is going to do. Some call for it to get wetter. So like our winters would be wetter. Some call for it to get drier. And so I'm usually tell people we really don't know how things are going to change in terms of the overall precipitation. But a shift to a drier climate in general, even if precipitation stays the same, because it's getting warmer, we're going to have increased aridity because the soils will dry out faster, water availability will go down. So drought is a pretty high probability forecast or projection for the future for around here. Yeah.
Going back to the previous question, you were talking about the warming of the climate and affecting elevation for precipitation. Are you saying that the lower elevations are going to receive more precipitation than the upper elevations as the climate warms?
No, I wish I had this figure to kind of show this. Think about it this way. The percentage of precipitation that used to fall as snow, that will fall as rain in the future, will be larger in the low valleys than it will be in the mountains. So say 40% of the precipitation that fell is, like with several degrees of warming, like 40% of the precipitation that used to fall as snow in Ogden is going to fall as rain, but maybe at the top of Snow Basin, it's 20%. And at 11,000 feet, it might be 10%. I always tell people global warming is not an equal opportunity offender. And when you hear them saying, well, it's going to be a disaster for ski areas everywhere, a lot depends on how much warming there's going to be, what the climate at that ski area is like, what its altitude is, how cold it is. I mean, one of the advantages that for instance, Colorado, I mean, not to give them too many props, right? But the advantage like Summit County, Colorado, those ski areas are extremely high. That's the last place on this planet that will be skiing in the future, right? That's the catbird seat, really, in some respects, with climate change. So, any other questions? Yes.
Could you explain the products that you give to the public at the University of Utah Atmospherics Department?
Yeah, too bad I'm not connected to the internet.
Like the MEES and the SAEF, like,
Yeah.
Power Buoy is really slinging it hard for you guys.
Hey, could you say that again a little louder, please?
Why is the high plume never right?
The high plume. Oh, the high plume. Yeah. Exactly. I thought you said, why is the powder buoy never right? So, you know, I always tell people that I'm not a forecaster, I'm a researcher, right? So I don't make the forecast you buy, I make the forecast you buy better, okay? So, and that's a blatant ripoff. When I was a kid, there was a company called BASF. That was their motto. We don't make the products you buy, we make the products you buy better. And I always tell people that's what I do. So I'm always trying to develop techniques to better forecast mountain weather, and in particular mountain snowfall, because that's what I'm interested in. So we produce on weather.utah.edu. That's a site that my group runs, and we do all kinds of computer model-derived forecasts for all over the Western United States. Some of the stuff we do is computer models today that do medium range forecasts, say that go out 2 to 10 days. They're not high enough resolution to see all the details of the topography of northern Utah, so we do what's called downscaling. We try to come up with ways to build in that detail. And then we do work with snow to liquid ratio conversion, which is really important. You've noticed a lot of the storms we've had lately are very, very dense. The snow to liquid ratios are relatively low, whereas other times the snow's a lot drier. So we have developed techniques to try to forecast that. These are typically machine learning approaches that we apply with these computer models. So we do quite a bit of that, and we produce the stuff online, and you can access it if you want to forecast the weather. We do a lot. The plumes are really popular. These are like, we take 52 computer models going out for, say, 7 days, and we show all those forecasts. And you can kind of see when it's likely that there'll be a heavy snowfall. These forecasts are definitely accurate, more accurate than the raw model output. They're definitely improved quite a bit. But they still have errors, they have biases. And one of the things we've really gotten beat up on this year is we've been way too high in snow liquid ratio. We've had a lot of high density snows, and we just haven't handled those very well. So what's that? The SWEs are really good for some locations, but they're much better across the whole Western United States. Is much better than the direct model output. So we do a lot of that kind of work. And then for a couple models, one is called the high resolution rapid refresh, which is known as the HRR. And then the GFS, the global forecast system, we do a machine learned product for Little Cottonwood. And I've thought about doing one for Snow Basin, and I could do one for Powder Mountain, but you got to give me a lot more free skiing. Yeah. Actually, let me take that back. The best thing that could be, because since my body's falling apart and I can't actually ski that much anymore, would be to talk to some students and convince them to help take some of my code and do it for Powder Mountain. Yeah, exactly. Yeah. So like for Little Cottonwood, we do from those two models, we use machine learning. We forecast, wind speeds, wind gusts, wind direction, snow level, that kind of stuff. Like the kind of stuff that you want when you're trying to figure out what's going on. And for me, I'm always trying to figure out when the next powder day is going to come and that sort of thing. And so a lot of the motivation for doing this is my own personal desire to have the best forecast products I can have. Yeah.
Are you guys using your own tools to generate the wind data? Or are you guys
Yes.
pulling from, what kind of stuff?
So in the case of the Little Cottonwood product, we take the last 3 cool seasons of forecasts from the GFS and the HRR model, and we train it to observations from Alta Mount Baldy. And then we apply that to the computer model forecast each day. So we do that. And
Use your own program, or is it like Wind Ninja?
everything we do today is in science is collaborative. So I can say I wrote my own code, but I'm running other pieces of code that other people have developed. So yeah, when we have our own quote code that we use, we access the data. Like for the ski areas that you provide data to MesoWest, we really appreciate that. Because for instance, Alta's been providing data to MesoWest for over 20 years now. So I can go back for some models. I haven't done this yet for the GEFS, which is a special type of modeling system. I got over 20 years of data. It's right at my fingertips. I can immediately start to train that if I want to and try to figure out what's happening. So we're really appreciative. I know Powder Mountain's been providing data. It's really helpful to us that we have that data. And it's in an archive at Synoptic Data and at the University of Utah. And I can just access it from the cloud. I can just say, I want this station, and boom, it pulls the data, and I can do some work with it. So we're really appreciative of that. And for anybody else at the ski areas, if you provide your data, we really appreciate it. It helps a lot. And for me, I get a lot of ideas sometimes of problems to work on from looking at the data. So people are starting to get tired in the back. I think they want more beer. So one more question, maybe.
So on the plumes, like there's lots of lines, right?
Yeah.
And then you like put the average in.
Yeah.
The average is an act. All of the lines have an equal possibility of happening, correct?
Kind of, yes. If you look at a given modeling system, like those NACE plumes, that stands for the North American Ensemble Forecast System. There's two modeling systems that go into that, the Canadian model and the American model, okay? The Canadians, we love the Canadians. But it could be that the Canadian model, you shouldn't weight quite as high as the American model right now. Other times, sometimes the Canadians move ahead of the Americans, and we should be weighting them a little bit more. But the difference is so small that for the most part, I look at all those as equally likely. That's the good news. And the bad news is sometimes you get Mother Nature goes outside of that forecast plume. But, you know, that's much better than just looking at one model. That's how I would look at it. So, one more question. Weather.utah.edu. Great. Thanks so much, everybody, for having me up. I'm going to have another beer, so if you have more questions, feel free to come up and talk to me.